Hey everyone, welcome back to my channel. Today, we're delving into the world of electrical components, specifically contactors. Contactors are vital in electrical systems. They use them to control and switch circuits. Let's dive into the details printed on one of these devices. I have 4 different brands of contactors here. We're going to explore the details printed on them. Take a look at these beauties. We've got the chained NXC25, LSGMC40, Tico CU11, and Simeon's contactor. Now let's dive into the details of one of these contactors. We'll start with the chained NXC25. First off, let's check out the front side. Here you can see the brand chained, followed by the model number, NXC25. Plus, we've got labels for the terminals and contacts. L1, L2, and L3 are the main incoming terminals. T1, T2, and T3 are the out terminals of the contactor. They will connect to the motor. 21NC and 22NC are normally close contacts that will open when the connector energizes. 13NO and 14NO are normally open contacts that will close when the contactors energize. Now let's flip it over to the side, where we find some technical details. It says that this contactor follows the IEC EN 60947-4-1 standard. IEC is short for the International Electrotechnical Commission. The acronym EN, derived from IEC, represents the European standard. IEC 60947-4-1 is the standard for low-voltage contactors and motor starters. It sets standards for equipment with main contacts connected to circuits up 1000 volt AC or 1500 volt DC. These contactors and starters can't interrupt short-circuit currents. They need separate short-circuit protection. This edition includes updates. They are for EMC test alignment, durability stats, and a new annex for safety. This standard defines the requirements and tests for contactors. The notation IEAC1 equals ITH equals 40A refers to the electrical traits of a contactor or switchgear. Here's a breakdown of what each part means. I stands for rated operational current, or rated continuous current. The contactor handles the most current it shows. This is under normal conditions. AC1 represents a type of duty. The contactor switches resistive loads. These include heating elements and lighting circuits. If this stands for thermal current, or thermal rating, it represents the most current the contactor can handle. More would overheat or damage it. 40A. This is the rated operational current and thermal current for this contactor. In this case, the contactor can handle up to 40 amps of current under AC1 duty. In summary, this notation shows that the contactor is designed to handle up to 40 amps. This is for resistive load switching. It is rated to handle that current without overheating. Moving on, we see UI, 690 volts. UI equals 690 V is the rated insulation voltage of an electrical device, in this case, a contactor. U, this stands for rated insulation voltage, or rated impulse withstand voltage. The subscript, I, shows that the voltage is related to the device's insulation. 690 V. This is the specific value of the rated insulation voltage. In this case, the contactor is designed to withstand an insulation voltage of 690 volts in essence. This notation shows that the contactor's insulation can withstand 690 volts. It will not break down or fail. This is an important safety consideration in electrical design and installation. UIMP equals 8 kV. This notation represents the rated impulse withstand voltage of an electrical device. In this case, the device is a contactor. UIMP, this stands for rated impulse withstand voltage, or rated impulse voltage. 8 kV. This is the specific value of the rated impulse withstand voltage. In this case, the contactor is designed to withstand an impulse voltage of 8 kV. The impulse to withstand voltage is critical in electrical design. It shows the device's ability to withstand high-voltage surges. These surges come from lightning strikes or electrical faults. This notation indicates the contactor is designed to withstand a voltage surge. The surge can be up to 8 kV without causing failure. This table shows the contactor's ratings. They are for different voltage and current combinations under AC3 duty. This seems to be a table or chart. It shows the ratings of a contactor or electrical device. It shows them for various voltage and current combinations. Here's what each column likely represents. AC3 refers to the type of duty or application the contactor is designed for. It's common for industrial applications and inductive loads. V. This column shows the rated voltage values for the contactor, with two values separated by a slash. The first value is the lower voltage rating, and the second value is the higher voltage rating. For example, 220-230 means the contactor is rated for voltages between 220V and 230V. A. This column shows the rated current values for the contactor in amperes, kW. This column shows the rated power values for the contactor in kilowatts. This table shows that the contactor has different ratings. They vary with voltage. For 220V to 230V, the contactor is rated for 25A and 5.5 kilowatts. For voltages between 380V to 400V, the contactor is rated for 25A and 11 kilowatts. For voltages between 660V to 690V, the contactor is rated for 18A and 15 kilowatts. Now, let's flip the contactor over to the other side, where we find the coil terminals. Here, we see the notation A1 and A2 by the coil terminals. They show the coil's positive and negative terminals. Below that we have the rating 415V 50-60 Hz. This tells us the rated voltage and frequency for the coil. For 15V, this is the rated voltage for the coil, which in this case is 415 volts. The rating is 50-60 Hz. This is the coil's rated frequency. It can be 50 Hz or 60 Hz. These frequencies accommodate different regional power grids. You would connect the voltage source to these coil terminals. This would energize or de-energize the contactor. The specific voltage and frequency ratings ensure safe and reliable operation. This info is key for picking the right contactor for a specific use. It also ensures safe and reliable operation. So, there you have it. That's a detailed breakdown of the information on the chained NXC25 contactor. Stay tuned as we explore the specifications of the other contactors in our lineup. Thanks for tuning in, folks. Don't forget to like, share, and subscribe for more content like this. Until next time, take care.